Now I will start the solid state welding process under unit 3, and end of this lecture the student will able to learn about the friction welding, friction stir welding and thermit welding. They have got some idea from the about that welding process. What is solid state welding process? Solid state welding process, a group of welding process that produces the welding joint, means coalescence, at a temperature essentially below the melting point. Means the metal plates have joint below the metal plates due to creation of the heat. Means due to creation of the heat, some parts at the welding zone, some parts will be melted, and due to melting, that particular welding phase, it will be after melting, then it will after some time it will be joint, means it will create some solidified weld phase. And without the addition of the brazing filler materials, without using any filler material, the materials will be melted using some producing heat, and then it will create the welding joint. Friction welding, using that thing we have seen some particular pictures. You can see that generally friction welding is a solid state welding process that produces the coalescence by the heat, and heat developed between two surfaces and by mechanically induced surface motions, means due to continuous surface friction, okay, it will create a heat, and due to creation of the heat, the some parts here it will be melted and welded. Okay, then in that welding process, generally mechanical friction happen between two phases. Mechanical frictions will be happen, and due to creation of the mechanical friction, one is rotating unit, another is non-rotating unit, and one side we also give the pressure. Lateral force also we have applied to displace and fuse the materials. Means here we have seen that here one particular component will be fixed using some fixing devices. Some other particles, means that things will be connected or attached to the some particular rotating devices. Maybe we consider that is the chuck. So that part will be rotated, and that part is the non-rotating part, and to the particular non-rotating part we applied the pressure. Okay. Now what happens? Due to continuous rotation of that particular rotating part, it will touch to that particular zone. Okay, and from that side we give the pressure. Due to continuous rotation of that rotating unit, here what happens? The mechanical friction will be occurred in that particular zone. Mechanical friction will be occurred, and also we providing the pressure from that side. And due to continuous mechanical friction, heat will be generated, and due to creation of the heat in that particular zone, the particular zone will be melted. Okay, some parts will be melted, and due to melting, that particular joint after certain time that will be connected. Okay, and actually that is the upset process. Okay, that is the upset process, means due in that way that both the cylindrical part will be connected. Spin welding, types of spin welding. Here what happened? Now a rotating chuck along with a flywheel, means in that rotating chuck one flywheel there also you have connected one rotating chuck. In that rotating chuck we have connected some cylindrical type rod. Okay, another cylindrical type rod will be connected some fixing devices. We have connected another cylindrical type rod, and in that particular rod we have produced pressure, and that rotating part is continuously rotating. When attached to that particular attached zone of the rotating part and non-rotating part, it will attach and continuous rotating, and due to rotation mechanical frictions will be occurred across that zone, and due to creation of the mechanical friction, here heat will be generated in that particular surface, and due to creation of the heat, here some parts will be melted, and due to melting, after certain time melting, both the parts will be connected. okay, and then it will be solidified, and after certain times it will finally connect it. That is the spin welding. Now linear friction welding means here the parts, both the parts are not linear, okay, both parts are non-linear, means that is as like a block type material. So here we have seen that both the parts, block type materials, we have hold properly, okay, and also both the parts moving this side, moving this side, means moving this side, means some arrangements we have created or we have made, means due to creation of that setup we hold that both the parts, means in this way we have produced that part, means hold that part and also it will move that side, means one part will be fixed, other parts will be moved that side or that side, it will move, and due to continuous moving that side means in that side and moving another side, and due to to and fro motion it will create some heat in that particular zone, means mechanical friction will be created, and due to creation of the mechanical friction heat is generated and melted some part in that particular zone, and after certain times both the blocks will be connected, means after melting, after certain times it will be solidified and will be connected in that particular zone, means that is the linear friction welding. Friction surfacing. So in that cases we have seen that some particular substrate, that is the substrate, and that is the method, means that is the created the force, that is the table movement in that direction, table movement, that is the substrate, and that is the method. What it will do, means it will going that particular directions, means the table move in that particular directions, method coming in that particular directions. So due to that thing, that method will be created some friction in that particular zone, it will create some friction, and due to that frictions that method will melted, in that particular zone, means heat will be generated due to mechanical friction, and due to mechanical friction heat generated, and that heat will help to melt that particular method, okay, and when it will melted and it will deposited across this zone, it will melted across this zone, and that type of, means that metal will be deposited in that particular zone, means we want to weld in that particular zone, that's why the welding has been happened to that particular zone. Friction stir welding. Here what we have seen that a cylindrical type solder tool, that is the cylindrical type solder tool we have used, a profile probe, a probe is there, that is the particular probe, okay, probe means nip or pin type we have used, and friction between tool and solder, nip work metal, means we want to weld across these directions, okay, means one plate, that is the plate 2, okay, that is the cylindrical type solder tool. When we keep that solder tool is rotated and move in that particular direction, okay, when it will rotating, that tip also rotating, and continuous rotation of the tip and also created some pressure on that particular joint, means continuous friction will be occurred across this zone, between tip zone and across this surface zone, and continuous rotation friction will be occurred, and due to continuous mechanical friction the heat will be generated, and due to creation of the heat, that across the surface that will be melted and welded accordingly. What is the advantages of the friction welding? Now first, simple operation and simple equipments. In that friction welding, very simple operation and simple equipment. Less time equipment, means less time requirements, means it will rotated, then it will melted and easily welded. Another, low surface impurity, means here the impurities or contaminants is very less, and also less oxide films. Generally, very less amount of material will be melted. That's why the less number of means very less amount of oxide films will be generated to that particular weld zone. Another, compared to resistance bar welding produced improved weld at higher speed or lower cost. Means respect to other welding, it will create very good weld quality. Means produce very good quality welding. Okay, and also it produces the welding very low cost. Heat affected zone, here heat affected zone already have told that is very small, that's why very less amount of oxide film will be generated. Another, there is no flux or filler material. No flux or filler material we have used in that particular welding operation. And also less shortening of the component, means very less amount of component we have used in that welding process. Another, what are the disadvantage of the friction welding? Means this process is restricted to angular type and flat type for welding purpose. Means any types of shape cannot welded using that operation. Another, use only for joining small parts. Very small type parts we have joined using in case of friction welding, because in that welding process very small type parts we have hold in that particular machines. Very big parts or heavy type of parts we cannot hold in that machine. That's why it has some restrictions. Tube welding, very long time tubes. If we use very long time tubes, so in that machines very long type tubes we cannot hold in that machine. So it is very difficult to weld the long type tubes also. Another, any high carbon steels is difficult to remove flaws. Some high carbon steel, very harder material, that is very harder material. In that particular material, it is very difficult to remove the flaws. So that's why it is also restricted to that particular welding process also. Another, heavy rigid machine due to high thrust pressure, means here heavy rigid machine, so why it is required? Now, due to holding of that particular non-rotating part, we provide some pressure in that side. We provide some pressure in that side. So machine structure must be rigid in case of friction welding. What are the applications? First one, bimetallic engine valve, universal joint yoke, and also geared hub also we have produced. In that particular cases we have used that type of welding process. Another, aerospace applications, turbine blade joining, seamless joining, we have used that welding application in aerospace. Consumer, hand tools, sports equipment also we have welded using that welding process also. Another, industrial, means spindles, tappers, tools. In case of military, medical, marine, mining, hydraulic equipments, different equipments we have used that welding process. Means that is the drill pipe, here we weld using that welding process. Another, that bimetallic engine valve also welded using that friction welding. Another, diesel injector, here we weld there. And also gear hub, in that cases we use the friction welding and weld in that particular zone. Another is twist drill, we weld that particular zone. And so in that particular universal joint yoke also we have using friction welding and joint using that friction welding process. Friction welding, that is the cylindrical type rod. Vice, in that vice we hold the cylindrical type rod and using some cutting operation we cut that cylindrical rod. Just two parts we have divided. We want to weld in that particular zone. One part hold to the particular chuck, another hold to the, means if we are considering the lathe machine, one part is connected to the chuck, one part will be connected to the tailstock. Now tailstock move what? In that direction. Here one part will be connected to the chuck will be rotated and that part also rotated, and we give the pressure through the tailstock, and here we have seen that it will attached and it will continuous rotated, and here due to rotation the mechanical friction will be created, and due to creation of the mechanical friction heat will be generated, and that heat will help to melt the metal to that particular zone, and after means red hot condition will be created, means metal will be melted, and due to melting the in that particular zone both the parts will be connected. Melted and both the parts will be connected. After welding operation, then we stop the machining operation, means we stop the chuck. After a certain time it will be cooled and the red hot condition will be converted into solidified weld zone. Then we open that rod. And that portion we do some machining operation for removing that parts also. Using some chipping hammer we remove some other extra materials. We also do the some alignment. Means after that we removing some extra materials. During some machining operations we remove some extra materials from that particular welding zone. Finally we have got that type of welding face.